Hello students, welcome again to my channel DNA.12 Education. Students, today we are going to discuss a new topic in science, mathematics and physics, commonly in science. The topic is scientific notation and standard form. Once again, scientific notation and standard form. For my last video, you already watched my video about scientific notation and standard form 1 for multiplication and division. Today we are going to continue the topic to the subtraction and addition. Okay, students, scientific notation 2 for addition and subtraction. Okay, scientific notation for addition and subtraction. Scientific notation for addition and subtraction. Students, to evaluate the very small number and very large number in addition and subtraction, just follow these 3 steps. Number 1, adjust the powers of 10 so they have the same index or the same exponent. 2, add or subtract the numbers or coefficients. And number 3, the final answer must be in scientific notation. Okay, students, what's index or exponent? Look at this sample. 3.8 times 10 to the power of 5. 3.8 times to the power of 5. Students, what is 3.8 position? And what is the 10 power of 5 position? Okay, I want to explain you one by one. 3.8 is 1. We call this one coefficient. The 12 and 7.14 is the coefficient. Clear for one? So what is exponent or index? 10 to the power of 5 equal this one index or exponent. Okay, and 10 to the power of 3 is index or exponent. So clear, students? Okay, once again, 3.8 is the coefficient and 10 to the power of 5 is index or exponent. 7.14 is coefficient and 10 to the power of 3 or 10 cubed is index or exponent. Clear, everyone? Okay, go to the next topic. Okay, students, to make your calculation easy, please remember this rule. Okay, when the power increases, the decimal will move left. When the power increases, the decimal will move left. When the power decreases, the decimal will move right. When the power decreases, the decimal will move right. Look at this example. Okay, students, I have 2 examples for you. 3.835 times to the power of 5. Alright? Okay, for this coefficient, equal for SF, 4 significant figures. Right? And this one is power or index. Right? Okay, we can modify 3.835 to the power of something. Okay, the pointer is the decimal. Okay, please focus on decimal for the moving or the place of decimal. Okay, for example, when I change these powers to the power of 6, right? So 5 to 6 is increases, right? So when the power increases, the decimal will move left. So this decimal will move left. So it will be 0.3835 times 10 to the power of 6. So of course, we have to put here 0. Okay, look to the next example. When I move to 10 to the power of 4, so means 5 to 4 is decreasing, right? Remember the rule. When the power decreases, the decimal will move right. So this decimal will move right one step. So it will be 38.35 times. Clear, everyone? Okay. Okay, I still have another example. 79.145 times 10 to the power of minus 3. Okay? So when I change this power to 10 to the power minus 2, okay? So means minus 3 to the minus 2 is increased, right? Once again, minus 3 changed to minus 2 means increases, right? So remember, when the power increases, the decimal will move left. So this one will move left. The decimal move left. So 7.9145. Clear, everyone? Clear? Okay. Okay, I want to give you another example. Okay. Okay, what about if 10 to the power minus 3, and now we go to 10 to the power minus 4. Okay, everyone? Minus 3 to 10 to the power of minus 4 is decreases, right? Decreases. Okay? So when the power decreases, means the decimal will move right. Okay? So 7, 9, 1, 1, 5. The decimal is here, right? After 9. Because of the power, because the power decreases, so the decimal will move right. So one step from decimal to the right, so the decimal will be here. Right, everyone? Is it clear? Okay, once again, when the power increases, the decimal will move left. When the power decreases, so the decimal will move right. Clear? Okay, go. Okay, exercise 1. Evaluate 3 times 10 to the power 3 plus 2.6 times 10 to the power 4. Giving answer in scientific notation. Okay, students, these questions are very easy. Okay, these questions are very easy. Why very easy? Okay, our job is to adjust the powers. Students, here, this one the power is 3, and this one the power is different, right? Okay, students, we can adjust the power to 10 the power of 3 or to 10 the power of 4. Okay, we just adjusting to the power of 4. Ten to the power of 4. Okay, this is our target, right? Okay. Okay, students, 3 times to the power of 3 plus 2.6 times to the power of 4. So you have to change this power to be 4. 2b to the power of 4, right? Okay, when the power increases, so you have to change the coefficient or decimal, move left. So where's the decimal? Means the decimal is here, 3. So you have to move the decimal left 1 step. So the number will be decimal 3. Means you have to put here 0. 1. So, but here 2.6 times to the power of 4, no change because the power already 10 to the power 4. Now we have the same exponent, right? We have the same exponent right here. Now our job is to sum up this coefficient. Okay, students, so 2.6 plus 0.3. Okay, we got 2.6. So the answer is 2.9, sorry, 2.9 times to the power of 4. Okay, is everyone? Right? Okay. The instruction is giving you answer in scientific notation. Okay, already done. Scientific notation, you have to modify the number to leave 1 digit. Okay, to leave 1 digit before decimal. Done, right? Okay, so then, very clear. Good. Okay. But the second way, we can adjust to the power of 10 to the power 10 here. Okay, this is the second way. Adjust to the power 3. Means 10 the power of 3, right? Okay, now we're going to rewrite the equation. 3 times 10 to the power of 3 plus 2.6 times 10 to the power of 4. Okay, because our adjusting is 10 to the power of 3, okay, so then 10 to the power of 3, so this one already done. 3 times 10 to the power of 3 plus, but this one is still 4. We have to adjust, okay? Okay, we can write here 10 to the power of 3. So 4 to 3 is decreases, right? Once again, 4 to the power of 3. 4 to 3 is decreasing, right? So remember the rule, when the power decreases, okay, the decimal will move right. Alright? So the decimal will move right one step here. So it will be 26 times 10 to the power 4. Yes, students? Now we have the same exponent or the same integral. So we are going to sum up the coefficients. 26 plus 3 got 29. So here is 29 times 10 to the power 3. Okay, but the instruction is scientific notation. Scientific notation. Scientific notation means you have to change the number to leave one digit before decimal. So 29 times 10 to the power 3 means you have to move this decimal here. So 0.9 times 10 to the power of 4. So when we have one decimal, one digit before decimal, means scientific notation is done. Is it clear? Okay, so we go to exercise 2. Evaluate 5.6 times to the power 4 minus 7.6 times to the 10 to the power 3, giving answer in scientific notation. Okay, so then this question is very easy. Okay. Okay, so then 5.6 times 10 to the power 4. This exponent is 10 to the power 4, but this exponent to the power 3 different, right? You have to adjust the number, right? Just the power. Okay, better remove 10 to the power 4. Okay, because 10 to the power 4 is the highest. So 5.6 times 10 to the power 4 minus 7.6 times to the power 3. The 5.6 times 10 to the power 4 already done, the power of 4. But this one 10 to the power 3, right? You have to adjust to 10 to the power 4. 10 to the power 4, right? So this power increases, right? The power is increases means the decimal will move left. So it will be 0.76 times 10 to the power 4, right? Now we have the same exponent here. 10 to the power 4, 10 to the power 4. Now our job is to subtract 5.6 and 0.76. Okay, 5.6 and then 0.76. Subtract, right? So we put here 0. Okay, we got this one 4, right? This one is 5. So we move 4. 15, 8, and here's 1 4. Okay, so then is it clear? Okay, we got 4.84. Now for 0.84, we put here 4.84, and then we have the same power 10 to the power 4. Okay, give your answer in scientific notation. Done, because one digit before decimal. Okay? Scientific notation, done. Okay, so then go to the exercise 3. Evaluate 7.821 times 10 to the power minus 4 minus 2.11 times 10 to the power minus 4. Giving answer in scientific notation. Okay, giving answer in scientific notation. Students, when we check the power for the first item, 10 to the power minus 4. The second is 10 to the power minus 4. Same, right? Already same. Right? So, you don't need to adjust the power. You don't need to adjust the power. So, 7.821 times 10 to the power minus 4 minus 2.11, 2.11 times 10 to the power minus 4. Okay? Ready here? Same. Now we're going to subtract. Right? 7.81 minus 2.11, we got 5.711 times 10 to the power minus 4. Right? So, the final answer is 5.711 times 10 to the power minus 4. Is it scientific notation? Yes. One digit already before decimal. Okay, so the scientific notation is done. Okay, go to the next question. Evaluate 90.8 times 10 to the power minus 2 plus 2 by 11 times 10 to the power minus 1. Giving answer in scientific notation. So then this question is very easy. Okay? Okay, students? Okay, the first is you're going to check the power. Okay, this one, the power is 10 to the power minus 2. But the second number, the power is 10 to the power minus 1. So you have to adjust the power. Okay? Okay, we have to choose the highest power for adjusting. 10 to the power minus 2 or 10 to the power minus 1. Yes, correct. You have to choose 10 to the power minus 1 because minus 1 is higher than minus 2. Okay, so then 90.8 times to the power minus 2 plus 2.11 times 10 to the power minus 1. Okay, I think this one done. Okay, but you have to change this one. 10 to the power minus 2, we have to adjust to 10 to the power minus 1. Minus 2 to minus 1 is decreasing, right? Decreasing. Then minus 2 to 10 to the power minus 1 is decreasing. It is increasing, right? Once again, minus 2 to minus 1 is increasing. So, remember the rule. When the power increases, you have to move decimal to the left. Okay? So, this decimal will move left one step. Right? Is it clear, everyone? Okay, good. Next, so we'll find 9.08 times 10 to the power minus 1 plus 2.11 times 10 to the power minus 1. Right? Now we have the same exponent here. Now our job is to sum up the coefficients. right? 9.808, 2.11. Okay, now going to sum up 9, 1, 11, right? So we got 11.19 times 10 to the power minus 1. Okay, is 11.19 times 10 to the power minus 1 scientific notation? No. Right? So is not scientific notation. Yeah. Okay, because 11.9 times 10 to the power minus 1 should be changed to the scientific notation, means you have to leave one digit before decimal. This is decimal, right? So this decimal will move to the left, right? So we got 1.119. Okay, so the power will be correct, increase. It will be 10 to the power of 0. Okay, once again 1.119 times 10 to the power of 0. Now we got one digit before decimal. So this one is scientific notation. Clear one? Okay, go to the next example. Okay, student, we go through exercise 5. Evaluate 90.8 times 10 to the power minus 2 plus 2.11 times 10 to the power of minus 1 divided by 4.82 times 10 to the power minus 2. The instruction is use the calculator and giving an answer in scientific notation in 3 significant figures. Okay, students, please use your calculator. Again, the instruction is using calculator. Okay. Calculator. Ready. Yes, students? By using the calculator, you'll find that 23.2157. Okay, you can check it by using a calculator. 23.2157. Students, this number is not scientific notation yet, because before decimal we have 2 digits here. We are going to change this one to be 1 decimal, 1 digit left for decimal. So 1 step left to 0.3257 times 10 to the power of 1. Why we have to write 10 to the power of 1? Because here actually here is 10 to the power of 0. Okay, so then just remember 10 power of 0 is 1. So 0 to 1 is increasing, right? So the decimal will move left here. Okay. Now we have 2.3257 times 10 to the power of 1. Okay, this one is scientific notation, right? This one is scientific notation. But the extra instruction is 3SF. Okay, now we are going to check how many SF for this coefficient. Students, when we check number of the significant figures here, there are 1, 2, 3, 4, 5. There are 5 significant figures. Okay, there are 5 significant figures. But our job is to modify to be 3 significant figures. Okay, students? We are going to change 1 to 3 significant figures. So we have to change this number and stop on 2. Right? 1, 2, 3. 3S. Okay, so what about 5 and 7? 5 and 7 will be rounded up. Okay? Will be rounded up. So, students, 2.3257 times 10 to the power of 1. 7 will round up to 1. So 5 will be 6. Right? And 5 and 6 will be round up to 1 again here. 1. So we'll find the number is 2.33, right? Times 10 to the power of 1. So 2.33 times 10 to the power of 1. We got this one, 3SF, significant figures, and significant figures cover the scientific notation. Okay, students, so 2.33 times 10 to the power of 1 is scientific notation. Scientific notation, alright? And 2.33 is 3SF. Okay. 3SF, done. Okay, clear, students? The question very clear, and the answer.
From John Paul School, and I will start my 7th grade this year. I've joined QPC course since January 2020 with Mr. Jasper as my course tutor. Mr. Jasper did not only teach me the proper techniques of both maths and mathematica, but he teach me how to learn independently and how to stick into a problem to find ways of solving it. The course materials were good and it's based on my school curriculum. And the mentor approaching is also good. During the pandemic of COVID-19, we studied via the internet and it's also good. And I think Mr. Jasper is very good and it's a solid course. I learned a lot. Thanks, sir.
Hai, nama saya Cassius Nathanael. Saya adalah seorang siswa kelas 6 SD Penabur Harapan Indah Bekasi. Les di Bimbel QPC sangat menyenangkan karena konsepnya fun learning. Cara mengajarnya pun asik dan tidak membosankan. Selama les di Bimbel QPC, saya menjadi lebih mudah untuk mengerjakan soal-soal matematika. Karena di sini kita akan diberikan rumus-rumus jitu yang mudah dipelajari. Oke, salam.
Halo, salam pelajar. Nama saya Pascual Clayton. Saya siswa Kolese Kanisius angkatan 21. Saya di sini untuk memberi testimoni saya mengenai proses belajar saya di QPC selama masa karantina lockdown ini. Pertama, jelas belajarnya jadi lebih susah karena harus belajar online. Namun, saya berterima kasih mempunyai QPC untuk membimbing saya melewati perjalanan belajar online saya. Saya sama sekali belum familiar dengan proses belajar online. Saya sangat perlu bimbingan dan saya berterima kasih akan adanya QPC di situ untuk membimbing saya. Nilai saya pun akhirnya berhasil kekejar. Nilai saya yang 60 menjadi nilai 80 dan nilai saya yang 80 menjadi nilai 90. Itu adalah mata pelajaran IPA tuh. Jadi selama proses belajar online ini akhirnya kekejar juga nilai saya. Itu in part sangat besar karena bimbingan Sir Jasper dan QPC. Setiap malam kami belajar bersama untuk mempersiapkan diri untuk esok pagi belajar online. Jadi nilainya aman selama belajar online ini di QPC. Semuanya aman dan bahkan lebih meningkat kalau di kasus saya. Sekian dari saya, terima kasih. Salam pelajar.